All right. Y'all are here on a Friday night. How does that feel? Yeah, I got you. OK, so just wanted to start out with a question. I think people have asked this before. How many of you are Android devs? Oh, yeah, here are my people. Hey, y'all. So follow-up question, how many of you use enums in your code base? OK, and how many of you just hesitated to raise your hand because you knew that was a leading question that could get you in trouble? Yeah, I see you. OK, so I have some hypotheses about why we have these debates about enums versus intdefs, and it goes something like this. We're pretty sure that enums are more readable, easier to look at and maintain. We're also pretty sure that there's some overhead to using them. And then the third point, where the real problem comes in, is that we're not sure which one of those we want to be more. All of us aspire to be the type of developer that has code that's easy to maintain and easy to extend, and that when your coworkers look at it, they think it's a joy to work with. But we also all want to ship performant apps that the user loves. We want to be lightning fast. And so when these things are in conflict, we get really, really smart people who are on both sides of the issue. So in the spirit of doing things that are inflammatory and will make you hate me, I would like to give a talk. And I heard that you have to have a clever talk title, otherwise you get kicked out of the speakers club. So I decided to call it this. And it's called Two Stones, One Bird. If you're a native English speaker, you might know that this is a play on the phrase to kill two birds with one stone. And specifically, if you think that's a really weird phrase and have no idea what it means, well, it roughly translates to accomplishing two objectives with a single action. Now, we widely regard that as a good thing because we're lazy, or something. But what that brings up is this question of, if getting two things for the price of one is good, what happens when you have one objective and you have two different ways to accomplish it? Say you need some sort of hierarchy, and you can do that with intdefs or enums. Well, there's only one correct answer. Always. And because nobody in this room is a slouch, I'll modify this and make it more accurate to you. There we go. You want to win arguments on the internet. This is what we're all here for. We're all in computer science. Now, there are exactly two things that you need to do to win arguments on the internet. One of them is very important, and one of them is less so. So, here they are. Unfortunately for you all, I really can't help you with that first one. You either have it in you or you don't. I'm sorry. I know. This is tough news to break. But fortunately, we're here for this second part. This part I can help you with. So the genesis of this talk was that I've helped a lot of people learn Kotlin recently. And I have a Twitter account for some reason. And so between those two experiences, I asked people what they found confusing about the language. And I polled them, and I brought together a few concepts where when they came to the language, they said, I have these different ways of doing things, and I'm not quite sure which one to use. Can you help? And so I went and I did some research, and I can't say that I have all the answers, but I just want to present it to you so that you have some information with which to make your own decisions. OK. If you were in my talk yesterday, you know that it's in my contract. I have to mention this word at least once every time I talk about Kotlin, so whoever's counting, I've mentioned it here. KnowLability. It's the case that we're all familiar with. It's one of the basic building blocks of our programs, is working with things that are null, if checking if they're null, et cetera, et cetera. Now, say I have some simple model like this. It's a pin because I work at Pinterest, and it has a user who created the pin. It's nullable because we have partial API responses. So something that would not be out of the norm is that I take a view, and I take that model, and I say, if that user exists, please show it in the view. So if you're coming from Java land, you would probably write something like this, except for you're going to find that this will not compile. Now, you have no way of knowing this because you don't see the code base from which I pulled this example. But where we define the model and where we define the view logic, they're in separate locations, and you can't smart cast across them. more widely, Smartcast sometimes fails if it can't guarantee safety. And so, if you're studious, you might do something like this. OK, I'm just kidding. Please don't do that. You might have a better option and do something like this. OK, so here we've pulled it into a local field, and now Smartcast is working. It can guarantee that this value is not going to change between the time you check it and the time you use it. Great. But of course, that's not your only option. There's also something like this. So where does that leave us? KnowLability is one of the simplest cases that we can deal with, and already we have at least a minimum of 3 different ways to deal with it. So that brings us back to that int-def versus enum question. If we have these decisions to make, how do we go about making them? Well, I would posit that you would first stop at a style guide. And fortunately for me, I made these slides 2 weeks ago. And at that point in time, I could do something like this, and it would be accurate. But of course, life doesn't work out like that. And so now you have not 1, but 2 style guides released yesterday, just to prove me wrong. Thank you, Google. Thank you, JetBrains. I appreciate it. So we actually do have a style guide. We do. The problem is that in the case of the Google style guide, they're definitely trying to emphasize things that are hard and fast rules, things that can be enforced by tooling. And in the case of the JetBrains one, they are also giving you a lot of great information, like the Google one. But it's often at the level of how you construct your code. So if you have something that needs to call it versus this, et cetera, et cetera. And sometimes that leaves you wanting for higher level ideas around like, OK, not necessarily the code block structure itself, but what about conceptually, what do I do? And so for conceptual problems, you might think of looking at books or blog posts. But of course, we don't yet have this either. This one I'm right about. Thank you. It is true. We do not have effective Kotlin. Nobody has proved me wrong yet. And so then that leads us back in a circle to where we started, which is that, OK, we don't have the resources exactly that we need to understand these problems. So let's go with readability. You will never be able to use that word, though, without someone flanking you on the left-hand side with performance. Unfortunately for us as developers, these always seem to distribute themselves on relatively different ends of a spectrum. It is the bane of our existence, but it is our lot in life. And Jake makes a really good point about this, and he says, well, ideally, the most readable thing and the most performant thing would be the same thing. And if they're not, that's a bug, and I totally agree with that. But unfortunately, we don't always get what's ideal, and so sometimes we have to consider both, and we have to make some hard trade-offs. Now, my personal ethos, I slide a little bit towards that readability side. I feel like it's important and it reduces bugs. Where you land is up to you. I'm going to try to take both into a consideration with the talk, though. OK, so let's return to that example and start diving in. So we had at least 3 different ways to check for KnowLability. Now, one of them we might be able to rule out pretty quickly. There are use cases for it. It's not always bad. But it's often not great. So that leaves us with 2, which is like getting better. We're almost down to 1. 2 is only a little bit more than 1. And so one thing that we might dive into now that we've looked at, OK, we should probably consider both readability and performance, is taking a look at what this generates. And so here, there's a lot of cruft. We don't really care about it. The part that's really meaty that we actually want to look at is this. Now, if it looks exactly the same as what you just saw, that's because it is. It's not doing anything unexpected. What you see is what you get. Now, that's because we were writing very Java-y style code in Kotlin. Let, on the other hand, does not have a Java equivalent. And so you might expect that when we look at what gets compiled for the let case, it's a little bit different. And of course, you would be right. So here, if we focus in on what matters, you'll see that, oh my goodness, what is this? There is an extra assignment. Now, I don't know how you spend your Friday nights, but I don't have many friends. And so I like to look at stuff like this, because I wanted to know where this extra assignment was coming from. These are the bytecodes from the if null case. These are the bytecodes from the let case. And I was still stumped. I had no idea what was causing that extra code to get generated. I started running some permutations on it, so I was trying to isolate whether it was because of the scoping in the let, or the return value, or something similar. And what I found out in the end is, I actually have no idea. I didn't find anything out, sorry. The buildup, I know. But one thing that I could say is that I actually found out, with the help of Jake again, that it doesn't matter for a lot of us. And the reason for that is that when we use optimization tools like ProGuard, it's actually going to end up getting stripped out in the end. Now, if you're not using ProGuard, maybe an extra assignment like that does matter. I can't tell you what's best for your code base, but I can say that the difference between these two things on a performance level is pretty small, especially if you're using those optimization tools. So that leads us back to that readability format. If you're going to argue about the readability of this, you have a lot of time on your hands, because to be honest, these two things, they're not all that different. But of course, this is the simplest case that we have, and we're not always going to be doing a check like this. We might more often do something with two different null values. And here, we're starting to see a difference emerge in the readability of these two different ways of working with nulls. Now, one thing that I want to point out is that while I personally believe that let is more readable in this case, there is something to be said for the fact that if is always paired with an else. We learn that from the very first moments of our computer science journey. If else, if else. Maybe an else if you're really adventurous. But we know that these things come in pairs. And unfortunately, let doesn't have that same concept. We don't think of let and something else. We just think of let. And so that can leave us with a lot of cases where we have dangling code, which is that we handle the if case, and that other case, we just kind of let the code run through. A lot of times this can cause bugs, not always, but usually if you handle the case when data's there, you should also handle the case when the data's not there. This is easily remedied by writing something like or else for the let, but it's something that you should keep in mind. So there are a few pros and cons. Now also, if you like that top example, you're probably screaming at me right now saying, you don't have to do it like that. You can put it in one line. I still think your point is moot because this is not all that much more readable. You can optimize it, but at the end of the day, there's something really nice about those chained KnowLability accesses. So for that reason, I would say lean towards let. Now, that's a really controversial opinion, and so to make sure that nobody argued with me on the internet because I don't like losing, I backed this up with a very, very reliable source. I really like to do my homework. So Twitter said that let is good, and therefore I want to recommend it to you. And specifically what I mean by that is that I put out a poll asking all of you all what you use. And it came back that 93% of people are using let for this sort of null access of the $.let and using that to access nulls. Now, there are 8% of people who are using it only for its mapping functionality, and then 30% of people who are doing mixed, and then that 57% of only nulls. So if you add them up, 93%, if I got my numbers right, are using it at least sometimes for this null behavior. So you'd probably be in pretty good company here. Now, I should point out that this is not in the official style guide, so do it at your own risk. Sorry, can't help you there. But it does seem to be popular in the community. OK, now speaking of let, something that people tweeted at me all the time was about let's friends. You know, those with, apply, etc. functions. And so I figured, well, that fits into my talk. Let's dive in. Now, luckily for me, all of these fit on a single slide. So I'm going to go through the definitions because I think they could be illustrative. With looks something like this. The part that we care about, it has a receiver, and then it has a lambda with receiver. What that means for you as the caller is that you can do code like this. And of course, you can actually make this a little better. You don't need those explicit calls because you're passing in a lambda with receiver. So you might be saying, OK, what does it do with it? Well, it invokes it. Nothing crazy there. When would you want to use something like this? That's a better question. And the answer would be, if you have a group of related calls that are all being invoked on the same object. Something like this could very nicely be encapsulated in code like this. Here, I've used pseudocode to represent a DB transaction that you might have to open, commit to, and then close. So these things are all tightly coupled. They're all related to each other. And it makes sense to put them in their own logic block. They would also all have to be called on that one object. OK, so that's with. Let's take a look at apply. Looks something like this. You're going to notice immediately that it is an extension function. And it also takes in a lambda with receiver. Now, more interesting to us in this room is that it returns this. And what that should tell you at an instinctive level, that kind of block invocation and then returning this, is that I need this object, but I need to run a bit of code before I use it. And if that's ringing any bells, well, that's because we do things like this a lot when we initialize and configure things. We create them, and then we format them, and then we use them. So here's an example. I pulled it from Android because I could, because that's what I know best, but it's applicable in other contexts too. You might go ahead and create a text view and then immediately set its layout. Now, you don't only have to use it for initialization. I have seen people use it like this, which is doing some ancillary thing before you do a return. The reason this works is because you get this back, so you're still returning the object. You're just doing this thing before you do it, maybe marking a field as dirty. I'm less keen on this, but I've seen it, so it's an option. OK, now, moving through to let. This one you probably know about. Spoiler alert, it's still an extension function, all of these except for with R. It takes a block. It's not a lambda with receiver in this case. But, craziness, it returns R. Now, a lot of people don't know this because they use it strictly for that case when it's null. So this might come as a surprise. This is a totally contrived example that you would probably never do in real life. But here, I'm taking an input of a string, which is the username. I'm immediately wrapping it up in a view that can show that and returning the view. So this function signature is going from string to view. Now, that doesn't mean that you always have to use terribly contrived code. I asked for an example of this. This is from open source that Jake has written. And he said that he sometimes uses let when he is deeply within a chained call, and he needs to map a single object. Here you can see this line highlighted. And what we're saying is, list of it. I have this single object, and I need to transform its type. And so you can see that there's the let there, and there's also the map. And that's the distinction that we're making there. But no fear, you can also continue to use this for that KnowLability work that you're doing. It's totally up to you. OK, moving on to the last of these also. Now, it looks like this. By this time, you're probably getting tired of seeing this, so I'm going to zoom through it. Has a block, returns unit. OK. Now, we have those tingly stars. So again, you know that it's returning this. And the only difference between this and that apply case that you saw earlier is that it is not a lambda with a receiver. It's just a plain lambda that you're passing. So what would you use this for? Well, fortunately for us, we have some pretty sensical names. And if you've ever had someone while you're rushing out the door say, oh, and could you also? That's what we're doing here. So you are doing something that's returning this, but that functionality itself is Teta unit. And so a place that this could be really good is when you're adding some side-effected code within chains. The reason for that is that you want to continue on the chain as if you hadn't done that, so you need that object back, but you do want to insert something, maybe a println, something like that. OK. So now that I've recited all the definitions for you, you probably know when to use all of these things. That's all we needed, right? Except for it's not. And you know that that's not true because all of those definitions were listed on the website this whole time. And people come up with these charts anyways. Here's one that I created. If you don't like this one, don't worry. You can also take a photo of this slide. Here it is. It's a different way to see the same thing. All right. And there are these charts, and that's great. But the fact that you even need charts is a little bit problematic, right? We can have these, and they're very useful. But we would like to have some intuitive understanding of when we would use what. And the roadblocks in our way to developing that understanding, I believe, are these two things, which is that some of these functions return values that you don't necessarily need to use. Additionally, you can call regular lambdas within a lambda with a receiver. So that kind of muddies the water about what you can do and what you should do. So in order to clarify that, I wanted to give some canonical examples of where these things are useful to help you build an intuition and to help anybody who's starting Kotlin on your teams build the same intuition. Now, if you look at with like this, you can use it as an assignment. It's a little bit confusing, though, because the type of this thing would actually be Baz. I don't know if that makes sense to you. It doesn't make sense to me. You could go ahead and make it make a little bit more sense if you maybe give it better naming and don't have this foo bar nonsense. But still, it's probably not the most readable thing. So here's what I would propose instead. These are not to cover every edge case. You can find things where this is not true. But what it does do, I hope, is capture some common uses for these different library functions. So with, we already covered. Logically grouped calls on an object. Apply, initialization and configuration. Let, nulls and conversions of a single type. And also, ancillary or side effecty code within chains. Hopefully, if you keep these sorts of things in mind, you can have that intuitive understanding that means that you don't have to check a chart every time you try to figure out which one of these functions to run. Now, if you're studious, you may have noticed that I left one out. Glad you're paying attention. And that's because, one, I thought if I showed you all 5, you would just run out of the room and be scared. And 2, because I legitimately forgot about it and didn't want to change slides. So here it is, run. It has 2 different ways that you can invoke it. So one of them, you can do it as an extension function. The other you can call as a normal function. Let's take a look at both of these. So it has a return value, and it has a no argument block of code that it executes. So what does that look like at the call site? Something like this. And if you develop a conceptual notion of what this would be if you inlined it after you ran your compiler, it would be something like this. And that should immediately beg the question of, you wrote a function. Like, why do you need this? You already wrote a function. It looks like this. Why are you wrapping it in a lambda and then invoking lambda? Maybe there are reasons. I don't know what they are. But my mindset immediately said, OK, well, if that's not a great example, then what I must be missing is the return value. I didn't use it in that old case. And so if I use it, everything will make sense, hopefully. So I went ahead, and I changed this code snippet to use the return value. Here, if we inline it, it looks something like this. It still doesn't look that useful. But if you're like me, you might have felt the need to do something like this before. And it might have looked a little something like this, which is that you have an Elvis operator, you have something that's nullable, and if that happens, you want to invoke code, but you want to do it in a clean way. You don't want to just throw that lambda in there. It can kind of run off. And so you can do something like this to guarantee that before you continue execution of your function, you have a non-null type here. Either you got it from that field, or you instantiated it. Now, I'm not saying this is the only use case for run, but it's one that you can use. OK, so let's take a look at that second version of it, where we have the extension function. Now, this probably looks a lot like with, and that's because it is a lot like with. Here, with, we're taking in the T, and then we're taking in something that can be invoked on that, and then we're actually doing that invocation. In the other one, in run, we have the T as the extension function, and then we're passing in the block and invoking the block. OK, so what does that look like at call site? Something like this. Now, if you go and look at the JetBrains style guide, they're going to say that you should prefer these things when you're not using the return value. But I would hazard that there's also, and they also call out the KnowLability. I would hazard that there's also some differences around the assignment of run. For instance, it might be make more sense to you if you had val x equals something dot run as an assignment as opposed to val x equals with something. Now, that's just my opinion. The style guide that JetBrains gives you, and also what I would say, is to stick with one. So I would hazard that that's the one that you would want to stick with. If you need to assign it, maybe run would be better, maybe some of the other standard lib functions. But that is purely opinion, so I didn't put it on the slide because it's totally up to you at the end of the day. OK, now what does this look like? Well, if you really translate this into English code, it's something like this, which is you're doing that null check, and then instead of just having normal code within the null check, you're invoking it on an object. So it's very much like a case that you're already used to. This time, you're just removing those object calls from the front of the methods. So where that leads me is that I don't really have a good thing to bundle all of those comments that I just made. We were talking about the fact that run, you can prefer that over with when you have KnowLability because you can go ahead and use the question mark to call it. We were talking about the fact that you prefer with if you don't want to use the return value. We were talking about assignments. And so I don't really have a good way to bundle that. And the thing that I would maybe try to do is say, it's good for working with KnowLability. Maybe? I don't know. This one's a lot more wishy-washy for me. If you have opinions on it, I would love to hear them. I don't have an easy encapsulation of them, so I'm leaving it up to you all. OK, so that leads us to something else, which is array of ints. Now, arrays of ints can also be expressed as int array. And you might be wondering, OK, what's the difference? They seem pretty similar. And of course, I'll let you know. So background, primitive types in Kotlin tend to be compiled, or I should say, yeah, non-null types in Kotlin tend to be compiled to Java's primitives unless there is a need for them not to be, like so. And so if you have something like array of int, you can expect it to do something like this, which is create that capital I integer array. Now, your first question might be, OK, what if I need the primitive? Oh, actually, I forgot this slide was here. It does indeed, if you go in and look at it, this is what happens. Now, your first question is probably, how do I do the primitive version of this? And unsurprisingly, you have this int array. And so again, if you go in and check the code, looks something like this. No surprises there. And so the model that you can build in your head looks something like this. Now, why would you do the difference between these two? Why would you use a primitive versus a non-primitive array? Of course, performance. I'm not going to outline the performance implications because they're not different from what you already know. If you are going to use a primitive array in Java, you should probably still use it in Kotlin too. And likewise, if that wasn't important to your performance, you can keep using array of int as you would have done anyways. Now, just to say something on the topic, the reason that they're involved in performance is because this is a reference type, and this is a value type. But again, that's all I'm going to say on the matter, because it doesn't change your knowledge of this topic from Java. All right, now diving into delegates.notNull versus late init. So there are a couple of things that you can list off of the bat, which is that one works with vars, and it doesn't work with primitives. That's late init. And the other works with vals and vars, and also primitives and not primitives alike. Now, you might notice that delegates.notNull, it basically has no restrictions. And so that means that a forcing function is, well, do you need something that's val for some reason on a delegate? Or do you need a primitive? Because if so, you need to use delegates.notNull. But that's not really a good reason to use something, like to be forced into it. You should probably understand why you're doing it. So let's take a look at delegates. Specifically, that first word, which means that you have an object somewhere that is being delegated to. And what that might look like is something like this. I've pulled a delegate that's already shipped in Kotlin. I've pulled actually part of it because I needed to fit on a slide. And it looks like this. And again, we don't care about all of this code. The key things to note are that a delegate has a getter and it has a setter. What is it actually doing? Well, it has a field. And in the set, it's very normal. You take in the value, you put it in that field. In the get, you're returning the value, unless it's null, in which case you're throwing. And this is really the only thing that differs from what you would have otherwise written. This is a very standard getter and setter. The only thing we're doing here is we're adding that throw statement. So you might be thinking, I could write that myself. And you are totally, totally right about that. The reason we have delegates is because if you want to add custom access logic for your getters and setters, you don't want to have to keep rewriting it. It's a way to package that up once and be able to use it across different properties in your app. That's why it's there. Like, that's what we have it for. You would write this code, and you don't want to keep writing it, so you package it up in this nice package, and you can use it by delegates.notNull instead of copying it into every getter and setter. So that might lead you to the point of, OK, so that's what delegation does, and that's how it's implemented, but why would I use it? And unfortunately, I can't answer that question until I tell you a little something about late init. So I'll go ahead and do that. Unsurprisingly, late initialized is the fuller form of late init. And what it means is that you have to, well, the reason we need it, actually, is that you have to finish initializing things by the end of the init block. This is no surprise to anybody who's written Kotlin. But unfortunately, or fortunately, on Android, we have really, really simple life cycles. It's something that we pride ourselves on. We love it. And so instead of having init, we have onCreate. And it's awesome, totally awesome. But what that means is that our code, like this, is totally valid. Like, this is good code for an Android developer. And that's problematic because, of course, the Kotlin compiler doesn't have a way to reconcile our lifecycle with the one that it's expecting. And I used an Android example here, but it doesn't have to be Android. It applies just as well to things like testing that have setup methods instead of putting logic in it, et cetera. And so you need a way to get this to compile. It otherwise wouldn't, because it would say that it doesn't have the value that it needs. And so you throw in that late init. And OK, that's great. So now I know what both of those do. But why would I use one over the other? And the answer to that is that you should use late init when you can. Now, there's a caveat to that. I went up and talked to Andre about this because he knows a lot more about Kotlin than I do and wanted it straight from the source. And what I heard was that there are performance implications around delegation. It's part of the reason that I showed you why it was or how it was implemented was so that you could see that it's holding on, it has an object, and it's holding on to a value, and it has the getters and setters defined on that object. Now, unfortunately, that's a really hard thing to optimize. And so because of that, you have something like late init, which doesn't have the same level of overhead. So right now, something like late init, it's more performant than using delegates.notNull. And so if you can, you would probably want to use that. Now, going forward, the hope is that we can optimize delegates.notNull, at which point you would want to use those everywhere. But that's in the future. It's not now. And so the guidance for here and now for today would be to use late init when you can. Obviously, I said the forcing functions of primitives and vals. So if you can't, it's not like a single object is going to kill your code base. Delegates.notNull is a fine other option. But if you have to choose, if push comes to shove, this is the most up-to-date, as of 30 minutes before my talk, wisdom that you can have. OK, so inline functions versus custom getters. Which one do you use? If you have a simple user like this, you might want to wonder if, how do I know if they're tall or not? Now, I've arbitrarily defined tall people as over 6 feet. I don't know if that is statistically accurate, but for my code sample, it is. And so you can do something like this, which is to have a get. And if you say height is over 6 feet, great, you're tall. I mark this as a variable because people grow up, and so their height changes, and so this can't just be hard-coded in. Now, another way you could do something like this, of course, is with a one-line function like so. You might say, OK, when would I use each? If I have this sample data, you can look at the readability by seeing this at the call site, me.isTall versus me.isTall. And the readability is obviously not that different. It's 2 extra characters. Like, they read exactly the same. And so readability, in this sense, might not be an issue for us. Now, that leads us to, OK, well, what about performance? Let's check it out. Go in, look at the bytecode generated. And if you're very spatially aware, brownie points for you, you might notice that they're exactly the same. And indeed, you can tell this if you read Kotlin in action, which you should. And the quote there is that they don't differ in performance at all. They only differ in readability. So we just said that the readability really wasn't that different, and the performance is exactly the same. So is it a wash? Of course not. That would be too easy. Things that you might consider, putting under this property syntax. The name, the last name, the age. Things that you might consider putting under this function syntax. Cloning, friends, clear. And more widely, if you had to put words to those two categories, you might call the one on the left data, and you might call the one on the right actions. And specifically, there are a few properties of those two different words. Predominantly, you're using properties for something that's an attribute of a type that has access on the order of a field access, and that doesn't do any crazy side effects when you access it. If checking is tall turns the screen blue for a user, that's probably a bad decision. You don't want to do that. It's unexpected. People do not associate side effects with their property access. And so you want to be mindful of that. That doesn't mean you can't have any side effects. It just means that you should be mindful of which ones you sneak in there. Now, actions, on the other hand, tend to be more computationally expensive. You might do them if you're doing defensive copies or the like. And also, you might do it if you're returning different values. If for the same function invocation, you're returning something different every time, it should probably be a function. There's a reason that math.random is a function and not a property. OK, so wrapping that all up, you might guess that we probably don't want to use a function here. We want to use a property. And specifically, we want to do it for the reasons outlined. So diving into the very last topic that people tweeted at me about. When do we use asSequence? Well, there are so many different options for you in the standard library to work with collections. I actually had this scrolling, but it ended up taking over a minute to do, and then the Keynote app crashed, so I'm only going to show you these. But there really are a truly astonishing amount of options out there that you could use. So if we just take 2 of those options and build this very trivial sample, here I have no idea why, but I'm putting these ints in as strings. I'm then parsing them, filtering on whether they're greater than 2, and then counting up how many numbers that is. If you look at what that generates, it's a wall of code, but there's only a few parts of it that we care about, which are these ones. Now, this is still a lot of code, so I want to direct your attention to these 2 parts. If you are a denizen of the interwebs, you might have heard this word, or words, I should say, which is intermediate collections. And indeed, the things that I just pointed out are intermediate collections. And what's happening is that when we have something like map, we're creating a new list, and then we're using a for loop, and we're copying things that belong in that list into it. When we have the filter step, we're again creating a list, and then we're copying things into that list. And so those are intermediate collections. Now, the problem with intermediate collections that you'll hear a lot of people flag is that if you have very large collections, it might not be good to be copying all of these and to be having these new lists for every different step in your filter or your map, et cetera. And so people will tell you, well, OK, if you have a big collection, you just append asSequence and magic happens and your code base is awesome. But it's probably useful to understand what's actually going on under the hood there. Here is sample output for these 2 different cases. On the left, we have the one that we started with. It's not a sequence. It's just a regular streaming operation. On the right, we have asSequence appended. And you can see the difference in the output. So one of them is using all of those elements in the map stage, and then it's using all of those elements in the filter stage. And the other one is using one element through that whole stream, then another one, then another one, then another one. Now, it's worth noting that if I modify the calls to be like this, the right-hand side of the screen, it's not a bug. You don't get anything. And the reason for that is that you need a terminal operation on sequences, and you need it because it's lazily evaluated. And so if you don't ever actually tell it to evaluate itself, nothing will happen. So if you're doing sequences, and you go in and look at the code, it looks something like this. And what I want to call your attention to is specifically what's happening under the hood is it's holding on to a transform, and then as the iterator provides the next object, it's invoking the transform on that object. This is how we get that lazy evaluation. Compare this to what's happening in the non-sequence case, which is that we have a for loop, and we're just eagerly going over every item in the collection and applying the transform, and you'll be able to draw your conclusions about which one you should use. It all comes down to performance. And specifically, it comes down to holistic performance. So I was talking to Andre about this point too, because I wanted to make sure I got it correct. And we tend to have this model where we say, OK, well, if we don't use asSequence, we have intermediate collections. And if we do it, we have lazy evaluation, and that's great. Except for lazy evaluation, it's not free. And specifically, we have those objects that I just showed you on the previous slide. We're holding on to the transform, and we're invoking it. And because we're holding on to that transform, we can be doing things like capturing references. And things like that, they can get really expensive. So it's not as easy as one is more performant as the other. It's, of course, that dreaded, you got a benchmark answer. And I'm sorry I couldn't give you a better one, but it is what it is. So the rule of thumb, if you read any of the documentation, still stands. Use asSequence if you have a compellingly large data set. But you should also profile, because asSequence, it's not free. OK, that's all the code that I have today. I just wanted to wrap that up by giving a little story, a little background, which is this. We know that choice, it's everywhere. And we know that it can be really overwhelming. If you have ever walked into a supermarket and stood in the cereal aisle for more than 20 minutes trying to decide which batch of sugar you want to buy, you know this. You know that having so many options can freeze you in your tracks. But choice can also be good. I don't know about you, but I have a liking for things that are neon, specifically things that are neon and have bananas printed on them. And it's great because there's a store that sells neon-printed banana hats. You might not believe it, but it's on my head, so you have to. Yes, it is. And that's awesome, because it means that I have this really, really niche thing that I love, and someone sells it. And more broadly, that means that there's something for everyone. And so you can look at Kotlin in the same way, which is that choice can freeze you in your tracks unless you know exactly what you want. If you walk into an ice cream store and you don't know any of the flavors, you might be frozen with indecision. However, if one of those flavors is mint chocolate chip, which you know to be scientifically proven to be the best flavor of ice cream known to mankind, it is very easy to make that decision. You don't have FOMO because you know that that is exactly the right choice for you. So my goal in today's talk was not to tell you what you should or shouldn't do. It was to tell you how things are implemented and where they're going, and give you an intuition of what the costs of them are, what might be more readable, so that you can make that decision for your own code base. And with that, that's all I have. That's the end.